Hi, we are Group 20 Innovation in Research Technology to assess forest wildlife. My name is Julia and this is Adam.
So the motivation for our project is that we would like to be able to estimate wildlife densities in a forest setting. And we can do that with camera trap images, which are these cameras you set up in the woods and they'll take pictures of animals that pass by. The issue here, though, is that camera traps don't always detect all the animals that pass in front of them. So it turns out if you know the distance between each detected animal and the camera trap, you can correct for this problem. And so our project is to create/improve automated methods for estimating the distance between the camera trap and the animal.
And so here we want to explain how the user interface will work. So here we have a camera trap image and we want to crop out the top and bottom because it contains the metadata, which is not useful. And after copying the image will look like this. And then we run this image into an animal detection model called Mega Detector that can detect where the animal is inside the image and draw the bounding box around it. And then we run the image into a depth estimation model called Zoe.mk that generates a relative depth map. And the brighter the color, the closer the object is to the camera. And then through some calibration, we convert the relative depth map into a matrix depth map where we can read the distant information from here. And in order to determine which pixels inside the bounding bodies animal, we run it into a segmentation model that compare image from the same thing and compare the difference between the pixels. And the pixels that are different would likely be an animal, and it generates this yellow segmentation mask. And then we take the median of these pixels and then we extract the distant information, which in here the deer is roughly at 9.6 meters, and our model generate an area that's within 2 meters.
So to make this method accessible to researchers, we've created a user interface, and that looks like this. So a user would open their folder that has their camera trap images in it. And then they would be able to configure the cropping, again, to remove anything that is not the image. And then after that, you can calibrate each deployment, which will tell the computer how to convert from relative depth to metric depth. So here we have a reference image and the corresponding depth map down here. So say I know that this tree, because I was out in the field, is at 6 meters. This tree's at 7, and there's some points down here that are like 4, 4, 4. You can see this depth map down here updates, and we can read to make sure that the calibration was good. So going back, we would like to save that. Going back, now we can click run distance estimation. That will take some time, so we're not going to run that right now, but show you some pre-computed results. So this is what the results would look like. You have our camera trap image, the animal, the bounding box, where it sampled the point, and the depth. Here's the same thing, showing the segmentation mask that was calculated. And here's the depth map. And you can see where in the depth map it sampled the depth. Another example, here's a squirrel, segmentation mask, depth map. The results are also outputted to a CSV file for easy reading. So we hope to release this user interface soon so that researchers can use it to much more quickly estimate depths or distances to animals and thus get robust estimates of wildlife density. Thank you for listening.